Next, we will discuss on the possible sources of contamination in monoclonal antibody production. The risk of contamination is always present in a bioprocessing plant. Contamination will have a direct effect on the purity of the final production, as it impacts the product recipe and lowers the system productivity. The first significant source is viruses associated with the mammalian cell lines used. Examples of viruses available in the hamster cell line are the LCMV and the hantavirus. Virus-containing cells should be detected beforehand through immunochemical procedures like southern blotting or sensitive techniques such as the PC. Contamination could also occur during inoculum preparation of cells by other microorganisms such as molds, yeasts and bacteria. Such contamination can result in lower productivity of the antibody-producing cells. Therefore, strict sterilization techniques and frequent monitoring of the cell culture should always be performed. The next source is through cross-contamination, which may take place between process fluids, for instance, when more than one cell line is cultivated simultaneously in the same production area. Cross-contamination is also likely to happen through repeated usage of one affinity column. An antibody batch can be contaminated by leftover traces from the previous batch. The column should be stripped by subjecting it to harsh conditions such as a concentrated solvent, before reconditioning the column for the next batch. Now, we are going to look into the three main hazards associated with the bioreactor processing technology. The first is chemical hazards. In terms of chemical hazards, workers may be exposed to waste contaminants or hazardous chemicals by inhalation, ingestion or absorption. Acute overexposure symptoms may include irritation of the eyes, skin, and respiratory tracts. Similarly, the preventative measures would be to practice the usage of personal protective equipment to reduce overexposure to waste contaminants and other hazardous additives. Design of mechanical addition systems to minimize exposure could also be considered. As for physical hazards, workers entering tanks may be exposed to confined spaces with oxygen-deficient atmospheres. Prior to entry into tanks or vessels, testing of atmospheres within the space should be required and be in accordance to the Occupational Safety and Health Administration standard. For biological hazards, pathogenic substances might be emitted from the open aerator and leading to allergic reaction. Hence, partition needs to be done to barricade the reactor area and workers are required to wear PPE. Controlling these hazards can be achieved by properly implementing current good manufacturing practices, and the application of hazard analysis critical control point (HAC).